this is day 2 of the exponential functions unit, and today is all about growth and decay. All right, and of course we're talking about applications of these. So you can see the standard is here in case you wanted to know exactly what it was that we're learning. So the first part that you need to know is you need to know percentages. Okay, percentages are key here in order for us to find our rate for exponential growth or decay. So remember that percentages are always out of 100. So we're going to review that. So in order to change, you need to know how to change from a percent to a decimal. Option 1 is just to divide by 100. Option 2 is to move the decimal 2 places to the left. Okay, so I'll show you a couple of these and you'll fill out the rest. Let's do 3.05% as one of ours, and we're also going to do, so we're going to do that one, we're going to do this one, and we're also going to do 25%. Okay, so I'm going to do option 1 for 25%. I'm just going to divide it by 100. So when we say divide by 100, drop the percent sign and then divide by 100. You can use your calculator to do this if you need to, and it's just going to be 0.25 is the percent to that decimal. Okay, so that is 25%. Okay, and then what else you could do is, like on option 2, I'm going to drop my percent sign again, and I'm going to move my decimal place 2 places to the left. 1, 2. And of course I need a placeholder here, right, because I was supposed to move it twice and I don't have anything there. So make sure you add your placeholder 0, and I always like to have a 0 in front of that decimal. So my actual number or decimal for 3.05% is 0.0305. okay, so you will be doing 6.5, 2%, and 10%, changing those all to decimals. All right, so let's move on to actual exponential growth and decay. So first off, you should easily be able to tell, or you will easily be able to tell at the end of this video, whether these functions represent growth or decay. So it's going to represent growth or decay, and it's always going to be based on the factor. Okay, our factor is going to be our change, right? How we get from one number to the next, how we get from one y value to the next. That's our ratio, right? So our b value is what we need. Okay, our b value, which was our ratio previously, is now going to become our ratio. Is now going to become our factor. Okay, so b is our factor. And if you recall, the formula we used for exponential functions was y equals a times b to the x. So b was what was in our parentheses. Yes, so that's exactly what we're looking at. If our b value is bigger than 1, so if our b value is bigger than 1, then we've got growth. Growth. Which means on the flip side, if b is smaller than 1, then we've got decay. Okay, if it's bigger than 1, it's bigger than 100%, right? So you've got something bigger, right? Something bigger than that is growing. If it's smaller than 1, which means it's smaller than 100%, it is decaying. All right, so you're just going to be looking at these numbers inside the parentheses. So I'm going to do a and b with you. And compare them to 1. If it's bigger than 1, it's growth. Smaller than 1, decay. All right, a, we have 4 in our parentheses. That's our ratio, which we call our factor now. 4 is definitely bigger than 1, so it is growth. Okay, that is growth, a growth function. Dang it, I keep erasing, sorry. And then b, 5/7. That is a regular fraction, it's not improper, so I know that it is smaller than 1 because 1 for sevenths would have been 7/7, and 5/7 is smaller than 1. So I'm going to say that b is a decay factor. A decay function. You will go ahead and do C, D, and E. You will decide if they are growth or decay functions. So you'll identify those. All right, so let's move on. When we discuss growth and decay, or exponential growth and decay, we're going to use a slightly different equation than y equals a times b to the x. So for exponential growth, which of course just means a quantity increases over time, and decay would be the flip side where it decreases over time, you're instead going to have b is going to be replaced with 1 plus r, which again, r is that growth rate. Okay, so again, you have that here. So b is no longer here anymore for growth and decay. B is now become 1, pretty much 1 plus or minus r. Okay, it's going to be plus if it's growth and minus if it's r, where of course a is going to be bigger than 0, so it's not going to be a negative. Because, and the reason that is because when it's negative, it's, I'm trying to think about it. It's going to be negative when you don't have an exponential function. It's just going to be a function, a basic function. Okay, so next thing we do, again, y is still going to represent our final amount, a is still our initial amount, r is our growth rate, and t is our time. So no more with x, no more with b. Okay, and then x became time. So this is what happened to them. Let me not say equals, it just became those. Okay, b became 1 plus or minus r, and x became t. So that's what happened with the previous one is gone, and now these are the new ones. Okay, so again, if it's bigger than 1, and put this on your paper again, if it's bigger than 1, where what's in the parentheses is greater than 1. Oops, I've made less than. Oops. This should just be our factor. Our factor is greater than 1, and again, you can always have that still be b, that's fine. And on the decaying side, our factor would be less than 1. Okay, so let's go ahead and do some practice with this by finding the growth and decay rates. So I want you to identify the equations as growth or decay, then identify the initial amount, the growth or decay factor, and the growth or decay percent. Again, your factor is going to be what's in your parentheses. So go ahead and write that down. Your factor will be the number, will be the number in the parentheses. Okay, and the growth percent is different. Okay, so that's really your rate. So how much is it growing? That's what that means. How much, how much growth or decay? That's what I want to know. How much is it growing, or how much is it decaying? Whichever one is doing. Okay, so I will do A with you. Well, I'll do A, and you guys will do B and C. Let's do that. Okay. All right, so for A, this one, oh, never mind. A is already done. Okay, so A is already done for you guys, where we can identify that this is a growth function because my factor, which is of course in the parentheses, is bigger than 1. Since it's bigger than 1, automatic growth. Next, we have the initial amount, which is in front of my parentheses. That is my 3.5. Okay, that's where that came from. Next was my growth or decay factor. Again, go back to what's in parentheses. The growth or decay factor is that number in there, which is 1.03. Okay, that's what's in our parentheses. That is our factor. And finally, how much is it growing? All you need to do is say it's, again, your growth is 1 plus r, right? Equals the ended, this is the rate, yes? So if I'm trying to find the rate and I know the factor is 1.03, all I need to do is subtract 1 from each side, and I'm going to get the rate. So if I have growth, all I'm going to do is the factor minus 1, and it's going to give me the decimal that I need. Of course, you're going to turn it into a percent, which is going to be 3%. Okay? And that is how we got that. So I will do B with you. Okay, so first off, looking at our function, the first number is going to be our initial amount. Our initial amount here is 10,000. Our growth or decay factor, The factor is always what's in the parentheses. Well, what's in our parentheses is 0.95. So it's 0.95. That's smaller than 1. Since it's smaller than 1, that tells me I've got decay. And similar to how A was done, if you're trying to find the decay factor, you, again, if decay is 1 minus R, and that equals my factor, because again, if you're looking up here, we've got this, right? This is all our factor. 1 minus R is our factor, and same thing up here, 1 plus R is also your factor. Again, you just have a different factor if it's growth or decay, so it's a different way to find it. So our factor here was 0.95. And what I want to do is I'm gonna just say, okay, well, it's minus 1. Same thing as the growth. I have negative R equals negative 0.05. I don't want a negative R, I want a positive R, so it'll be R equals 0.05. Okay, just flip them, which translates to 5%. Okay, so my growth or decay factor is 5%. And I'm done. All right, so go ahead and practice with part C, and you should be good there. You also have example 1, 2, 3, and 4 for the real world examples. And again, same type of deal, but this time I'm going to ask you to write the function as well. All right, so I'm going to do example 1, and you guys will be left with 2, 3, and 4, which will finish out your day 2. All right, so example 1 says the original value of a painting is $1,400, and the value increases by 9% each year. If you notice, I said increases. If it's increasing, that means they specifically just told me it's increasing, which represents growth. Okay, which means that my function should be a growth function. Okay, and it's increasing by 9%. It told me how much it's decreasing or increasing, which is my growth rate. Okay, that's my growth rate. This tells me I should be using the formula for exponential growth. And the exponential growth formula is y equals, oh, they want a function. I'll make it as a function then. So instead of using y, I'll just use f of x. Oops. F of x is going to equal a times 1 plus r to the t. Okay, where t was time, r is rate, a is the initial value. And I'll put that on here. Time, rate, and initial value. Okay, so since that is my function I'm supposed to be using, I need to identify my initial value and my rate and how much time I need in order to, I guess, figure out what they want. Okay, so our initial value, they literally say that the original value, which is, I mean, it's just right on the head, right? They say the initial value of the painting is $1,400. They literally just told me the initial value is $1,400. Initial value is A, right? So it's $1,400. I'm going to go ahead and put that there. Cool, done. The rate, how much is it increasing? That's what they want, right? How much was it increasing by? It was increasing by 9%. Okay, that was my growth rate. Oops. That was my growth rate. And it equaled 9%. They said as a decimal. 9% as a decimal. Remember, you can have two options. You can either divide the percent by 100, because percent is per 100, or you can just say 9% and move that decimal twice to the left. Oops, twice to the left. 1, 2. You need a placeholder, so it's 0.09. Okay, and finally, write your function. All right, so our function, remember again, you need to have 1 plus r, and again, I will have f of x. I'll write it both ways and then I'll simplify it. So I'll have f of x equals a, which is 1,400, times 1 plus rr, which is 0.09. That's why we needed it as a decimal, so we can add it to 1 to the t. Okay, but 1 plus 0.09, you can simplify that to just 1.09. and still raised to the t power with 1400 in the front. Okay, finally, they wanted us to find the value of the painting in 25 years. All right, so all I'm going to do, again, t is time. The only thing I need to do is plug in 25 for t. So instead of having a t, and you would just rewrite this to be 1400 times 1.09 to the 25th power, and use your calculator to find that. So I'm going to go ahead and use mine. So I had 1400 times 1.09 to the 25th power. And I got the answer of, and I'm just going to erase this so I actually have some space. Hopefully you're not writing as big as I am on your paper, so you have some space there. But I found that my solution of this, the value of that painting, is going to be $12,072. And again, you need to just round it because they didn't really tell me what to do, so it's money. I'll keep it there. $12,072.31. Okay. If they wanted it by the nearest whole number, we just say $12,072. Okay. Either way, it works for me. Okay. So it is really, it is very straightforward here with exponential growth or decay. Yeah. So that should be pretty much it. All right. So that is it for day 2. You go ahead and you will be doing examples 2, 3, and 4. Once you finish this, you will need to review, practice a little bit with this with your Delta Math. Again, that should be your next assignment here. All right. Thank you.